Hey everyone, welcome to The Explainer. If you're gearing up for your software engineering finals and need a rock-solid, high-yield study guide to memorize the GR4ML framework, well, you've landed in the exact right spot. Grab your notes, get comfortable, because we're going to break down exactly how to align business goals with machine learning design, layer by layer.
Okay, here's our syllabus, mapping out the journey for today. We'll be covering 1. Why machine learning fails. 2. Meet GR4ML. 3 core views. 3. Business view, the why. 4. Analytics design, the what. 5. Data preparation, the how. And finally 6. Bringing it all together. Let's get right into it.
Section 1. Why machine learning fails. So before we can appreciate the solution, we really need to understand the crash. Why do so many machine learning projects just totally fail, even when we have amazing algorithms and mountains of data? As engineering students, it's super tempting to think, hey, if I just have enough data and a beefy enough neural network, success is guaranteed, right? But honestly, in the real world, that is simply not true.
The real culprit? It's misalignment. When the business request, the analytics design, and the data preparation are totally disconnected from each other, even the absolute smartest ML engineers are going to end up building the wrong model. Think about it. The business asks one question, the data teams prep completely unrelated data, and you, the engineer, are caught right in the middle, building this highly accurate model that solves absolutely nothing. Yikes.
Section 2. Meet GR4ML. 3 core views. Enter our overarching solution to this massive headache, GR4ML, which stands for Goal-Oriented Requirements Engineering for Machine Learning. It exists entirely to ensure your ML solutions actually solve tangible business problems. Think of it as a bridge, a conceptual modeling framework that firmly connects the business, the analytics, and the data, making sure everyone is speaking the exact same language right from day one.
All right, so the absolute most crucial point for your exam is this simple mnemonic blueprint. Why, what, and how. Everything in GR4ML boils down to these 3 steps. Why do we need it? What is the analytic solution? And how do we prepare the data? Seriously, burn this flow into your memory right now.
Section 3. Business view, the why. Defining the project goals is where the magic starts. Every single successful project begins by asking, why are we building this system in the first place? Remember, you aren't just writing code, you're enabling decisions. This view focuses strictly on the high-level goals, the specific decisions that need to be made, the exact questions that need answering, and the metrics that will actually define success.
Now, to make those abstract business terms stick, let's anchor them to a real-world scenario. Imagine a bank loan officer. Our actor is the loan officer. Their strategic goal? Minimize defaults. To do that, their decision goal is figuring out whether to approve or reject the loan. So the question they need your model to answer is simply what is the probability of default? The insight is the actual output, like say an 85% risk score. The indicator is the default rate, updated monthly, and you're looking at a learning period of the past 5 years of data. If you can map out a scenario exactly like this on your test, you are going to absolutely ace this section.
Section 4. Analytics design, the what. Moving down the stack, let's see how this builds on those business requirements. The analytics design view is where you figure out what specific computational solution will generate the insights the business actually needs. You're basically translating those business questions, like our loan officer's default probability, into a strict mathematical analytical goal.
You'll really want to memorize these 3 sub-goals because they dictate whether your model is just analyzing past data or actively driving future actions. First, a description goal just understands patterns, like identifying the traits of risky customers. Next, a prediction goal forecasts the unknown, literally predicting if a specific customer will default. But then a prescription goal takes it all the way to recommending an action, explicitly telling the software to suggest approve or reject. Knowing the difference between describing, predicting, and proscribing is absolutely key.
Your analytics design also requires picking the exact algorithm and defining your soft goals. And listen, in highly regulated industries like banking, a soft goal like interpretability is just as mandatory as pure accuracy. Think about it. If a complex neural network denies someone a mortgage, the bank legally has to explain why. You can't just point to a black box. This quality requirement might actually force you to choose a much more interpretable model, like a simple decision tree, fundamentally shaping your entire engineering approach.
Section 5. Data preparation, the how.
Welcome to the foundational layer. Honestly, this is where you're probably going to spend about 80% of your career.
Even the most perfectly designed algorithm will totally crash and burn if this data preparation layer is neglected. This view answers, how do we prepare the data? By focusing on the really gritty work of transforming raw, messy data sources into clean, usable features.
It's super helpful to categorize your data prep tasks so you understand the difference between fixing errors and shrinking your data set. Data cleaning is all about fixing things, handling missing income values, or smoothing out noisy records. Data reduction, on the other hand, is about efficiency. It's using techniques like feature selection or PCA, principal component analysis, to mathematically shrink the size of your data without losing any vital information.
And these concepts map directly to the tools you'll be using every day. Your entities are your raw customer tables. Your operators are how you filter and aggregate that data. Pre-processing involves normalization and one-hot encoding so the math actually works. And the mechanism? Well, that's the underlying implementation. Usually your heavy lifting, extract, transform, and load, or ETL pipelines, pulling the whole shebang together.
Section 6. Bringing it all together. Okay, let's zoom out and synthesize this into one cohesive, exam-ready flow, starting right at the top with the business view. Our bank caseworker needs to reduce defaults by answering if a specific applicant is risky. This is the pure, unfiltered why. The business need is explicitly defined here before you even think about writing a single line of code,
which perfectly dictates our analytics view. Knowing the why tells us exactly what to build, deploying a model to predict that risk. Now you might see random forest listed as a possible algorithm here, but think back to our chat about explainability. If your soft goal demands high explainability for banking regulations, you'd strategically pivot away from a black box random forest to a transparent decision tree to prescribe that approve or reject action. And finally, down at the base, we have the data view. Our ETL pipelines pull from the loan tables, specifically cleaning those missing income values to feed that exact algorithm. This is the how. See how it flows? The data prep is entirely guided by the analytics, which was entirely guided by the business.
Seriously, if you remember only one single thing from this entire explainer for your exam, memorize this continuous flow. Why are we building it? That's your business view. What analytics do we need? That's your analytics design view. How do we prepare the data? That's your data preparation view. This flawless alignment is the entire essence of the GR4ML framework.
So I'll leave you with this. As you head into your exams and eventually step out into your future engineering careers, always let this question drive your architecture. Is your next machine learning project actually solving a real business problem, or is it just another model? Don't just build models in a vacuum, guys. Build solutions that matter. Thanks so much for studying with me today, and hey, good luck on those finals.